All right, let's talk about combustion reactions. This is on page 11 and 12 in your packet. And I'm going to just spend a little bit of time on these. You'll get to see a pretty cool demo in class. You're going to get to see the gummy bear execution. And also you're going to get to see another demo that what we call the whoosh bottle. Okay? But just to give you some idea on a YouTube video of what a combustion reaction is. So the first thing with combustion reactions is you'll really like them. And the reason that you'll really like combustion reactions is they usually involve significant amounts of heat transfer. Okay? So what ends up happening with a combustion reaction is we end up with some type of hydrocarbon. What does that mean? It means something that contains carbon and hydrogens. Now I'm using X and Y because it could be any number of them. And we can also throw other elements on the end. You know, we can have oxygens, we can have nitrogens, etc., etc. But as long as it has this carbon and this hydrogen piece, it's considered a hydrocarbon. Okay, so we see a hydrocarbon there, right? And it's going to react in pure oxygen. So yes, it must be in pure oxygen. Remember, oxygen is a naturally occurring diatomic. So oxygen is represented by O2. Now, what we end up making as a byproduct of this is a couple of things. We always make a gas, and that gas is carbon dioxide. And likewise, we also make water, HOH. You can call it H2O here. It doesn't help you as much for balancing purposes to call it HOH, but I just like doing it, okay? So again, hydrocarbon, pure oxygen, making carbon dioxide and water. And these are pretty darn simple, all right? So I'm going to go on page 11 now, and I'm going to do number 1. So on page 11, number 1, it says methane gas, CH4. So CH4 burns in oxygen. So that's plus O2 to form carbon dioxide and water. Okay? So there's the reaction for that. When you go ahead and do this combustion reaction, you would know all the different pieces and different components that go into it. And then from there, what you would also have to do, just like any equation, is you would have to balance it, right? So when I do this balance, I believe it's 1, 2, 1, 2. Now how do I make sure of that? 1 carbon, 1 carbon. 4 hydrogens, 2 plus another 2 for 4 hydrogens. Here it's 2 times 2, it's 4 oxygens. 2 plus 2 times 1 is 2 more. So 2 plus 2 more is 4. So therefore, it balances. Hardest part on combustion reactions is being able to balance them. I mean, by a lot, okay? Let's take a look at the second one right now. It says butane, C2H6. C2H6 burns in oxygen to make carbon dioxide and water. Again, same skeleton as the previous problem, right? Only thing we got to do now is we have to balance it. Now, with this one, you're going to probably try some different things. I'm going to do it wrong first. So what I would notice here is I would say, okay, to myself, I'd say self, what if I tried a 3 right here, right? That gives me 3 hydrogens and 3 hydrogens for a total of 6 to match the 6 hydrogens here, right? Well, I could find myself saying, okay, let's go ahead and give myself 2 for 2 carbons and 4 oxygens. But here's my problem, okay? When I go 2 times 2, that gives me 4 oxygens plus another 3 times 1, which gives me 3. So that's a total of 7 oxygens, right? That's a problem because I can't do partial numbers. It's not allowable. So the fact of the matter is, I'm just wrong. So I find myself saying, uh-oh, okay, I got to get rid of these coefficients. So I say, okay, I got to try something else. I also know, from what I just learned, that the number here has to be even. Why? Because we need something even plus another something times even to equal something times even. All right, just mathematical concepts. So what I found myself saying is, okay, instead of a 3, what if I tried a 6 right here? that gives me 6 hydrogens and 6 hydrogens for a total of 12. Well, that's okay because I'll put a 2 right there. That gives me 2 times 6 for 12. Then 2 times 2 is 4 carbons, right? So I say to myself, okay, if I put a 4 right there, that gives me 4 carbons. But it also gives me 4 times 2, which is 8 oxygens, plus another 6 times 1, so 6. So 4 times 2 is 8, plus 6 more is 14. What times 2 is 14? 7. 2, 7, 4, 6. And now you have a balanced equation. And those are combustions. Pretty simple. Again, hydrocarbon, oxygen, carbon dioxide, water.